Thanks, Tracy. Thanks, David, for having me. So I'm going to talk to you about a survey that just completed. I'd like to thank my colleagues, Nicole Hutchinson and Megan Clifford, who's on the call from Stevens Institute of Technology, and also Eileen Van Aken, Alejandro Zaledo, and Caitlin Henderson from Virginia Tech. Between the six of us, we organized this survey and the results. And I'll talk a little bit about how this came about. I did put on chat the location for the survey itself. So if you want to read the survey results document, and also the copy of these slides are available at that link on the CERC website. System Engineering Research Center, it's a Department of Defense sponsored university affiliated research center focused on system engineering methods, processes, and tools. And we work broadly across universities. We have 22 universities in the U.S. as collaborators in this research center. And then we do work with others as well as professional organizations as we go along. This kind of got started at a meeting at the International Council on Systems Engineering's International Symposium last summer. And that meeting was between ourselves and leaders in NCOSE and leaders in NDIA, the National Defense Industries Association. And at that point in time, NCOSE had basically finished up a thing called the Capability Maturities Matrix, which I'll talk about a little bit more. And the desire was to go kind of capture a benchmark at that point in time on how organizations are doing with their digital engineering transformation. And the idea of using the capabilities matrix sort of formed the heart of that. So we went into a process following that where we developed a survey, and a set of questions that came from were based on this capability matrix, and then put it out there. It was open from November through the end of January, and this will talk about the results of that survey. So we go through here. So I'll just mention a few things here. The DoD engineering strategy was the top level framework for organizing these results. I'll applaud Phil Zimmerman and her team. We've worked with them for several years now, and one of the things we did in 2016, 17, 18 timeframe was we built a conceptual model of what the future acquisition system would look like for the Department of Defense when it had completed its adoption process, its digital engineering transformation. And so as part of that conceptual modeling activity, we participated in the development of the engineering strategy, digital engineering strategy, although we didn't drive it necessarily. At the end of that process, the strategy that they did release matched the model pretty well. And a couple things out of that process. First of all, it's actually quite useful document for anybody who's doing digital engineering transformation. Its vision, mission, and goals can be quite generalized in that space, so I would encourage folks to read through it. And the other thing was that the people that we interviewed in that conceptual modeling process, for whatever reasons, were saying the same words that the strategy produced, but they were doing them independently. So it did capture the tone of change at that time. Meanwhile, Al Hoheb from Aerospace Corporation and Joe Hale from NASA Marshall Space Flight Center had been working together on a thing called the Model-Based Enterprise Capability Matrix. And that was brought jointly to them after they had compared their notes to NCOSE. And then the NCOSE MBSE working group went through basically 5 evaluations over a period of 2 years or so to mature this capability matrix. And so it was published formally as an NCOSE document in January 2020. And it became the basis for the survey questions. I would not necessarily call this a maturity model, but it defines the things that organizations have to do to build and mature their enterprise-wide digital engineering capabilities. I won't go into a whole lot of detail on this, but if you're interested and you're an INCOSE member, you can get it from INCOSE. Aerospace Corporation has also developed an interactive website where you can go assess yourself against the matrix and enter your data. Al-Hohab has actually put together a half-day workshop that organizations can use to help them in this space. So kudos to them. A couple things actually came out of this process. So what we'll talk about in the survey results is a framework that was developed to look at value, benefits, and metrics associated with digital engineering. And Phil showed that previous slide, which I'll talk to in a little more detail on measures of quality, velocity, agility, user experience, and knowledge transfer, which came out of that. Most of that work was done by a PhD student at Virginia Tech, Caitlin Henderson, who we acknowledge here, to develop that framework. So part of the useful results of this survey is actually this framework. And the document goes into its development in some detail. The other thing that came out of this process was the development of a separate enterprise adoption framework that's not so much associated with the DE and MBSE processes themselves, but associated with the organizational change process. Dr. Eileen Van Aken at Virginia Tech developed this framework linking the Baldrige capability assessment framework into this space. So if you're familiar with the Baldrige Award for Quality, this is the formal assessment framework that's used by many organizations from that space. So we'll talk a little bit more about each of these frameworks as we go along. Another view of the DoD digital engineering strategy, just to kind of tell a couple stories that link to the process or the discussion from earlier. You can see if you think about the detailed process, methods, tools, technology, people, culture, all those other kind of things that flow up through the strategy process, that the 5 goals of the strategy can be informed by the details, the initiatives and ways to means and ends that are documented as effectively sub-goals in the digital engineering strategy. Understanding that where we are, the big shift that we're seeing in the digital engineering domain from, you can talk about the period of the 90s into the period of the 2000s today, is this idea of authoritative source of truth. And that authoritative source of truth is the common data set that everybody uses linked to shared models. And we can kind of hand it to Jet Propulsion Lab. They were really the first in this space to start exploring the idea of how do we manage models around a common data store. And they, fortunately for a lot of us, they released their tool set that they built to do that. It's called OpenMBE. And so a lot of the programs now have adopted OpenMBE as a common data and management framework. So in that story, then you can see there's a lot of technological innovation that's been going on to link models together, and more needs to go. And the tools are maturing in the infrastructure environments. The big shift, or the big process we've got to get through, and the survey brought this out pretty clearly, is really transforming culture and workforce in the space. So we kind of know what we do at this point in time, but the big cultural shift is going on. So one of the first things that we kind of did as we were going into this was look at, all right, so if we want to understand how things are moving, things move towards what you measure, and how would you measure? And so we looked to the broader world of digital enterprise transformation through experts in that field, and identified a set of what you might call good across-the-board digital transformation metrics, assuming that the challenge here is digital engineering transformation more towards the transformation side. And so these are some of the things that came out of it. We did some studies. We linked in closely with the Agile world and the DevOps world because they've been doing a similar transformation in the software world. So we built a broad categorization of 5, you could call them success areas or success measure sets, centered around quality, velocity, agility, user experience, knowledge transfer, and adoption. So one of the things that was unique in this process was the idea that knowledge transfer is a key category. And if you think of the job of system engineering as to be integrating teams and integrating information together to manage the complexity of our product, that makes a whole lot of sense. But it's something of a unique set of practices in the digital engineering domain that don't necessarily exist in other digital transformation domains. This shows some of the kind of top measures that came out of that. We're going to go in detail into what those were. So back to Caitlin's work. So our student actually read 847 papers that mentioned model-based system engineering and sorted out 360 that linked to benefits and value in this world. And so at the time, which was several months ago when she finished this study, you can kind of see some statistics out of that out of those 360 papers, she identified 236 that perceived gains from their digital engineering or MBSE strategies, 27 that observed it, and 2 that had measured it. And so this is kind of where we are. Maybe kind of part of the importance of the group here at SysView is that we see a lot of benefit from this process, but we don't have good frameworks for measuring the actual benefits yet in the space. So as a result of that, we identified 48 categories of benefits that link to metrics across 4 of those broad change areas. And we brought that per agreement with the survey sponsors into the survey to help us evaluate the data. And it turned out to correlate pretty well. So these are the list of benefit categories, the total 48. For those of you here that are interested in quality, I'm not going to go through all these, but this is, there's I think 17 what we might call benefit categories that are associated with quality. And you have to think of these as high-level benefit categories, so they're highly abstracted at the survey level based on people's language. The details of how you would actually measure this still have to be developed in a lot of areas. But you can see things like reducing errors and defects and improved traceability as being 2 tops in that category. So we'll kind of produce data that supports all of these categories as we go through the survey results. I'll just show you the quantitative results of the literature review as it comes out of this process. And so you can see things like reducing errors and defects, which maybe would be obvious results of modeling activities up front, have been measured, they've been observed, but they're actually perceived to be slightly lower in value. And maybe this is because we're talking about system engineers who would normally be focused on improving the traceability from mission to requirements and concept and design as you go through the process. So that was high in terms of the perception, although it has been observed and measured less. And I think that's where we are in the process. You can look at velocity and agility and see collaboration and information sharing are the high level perceptive things that users have, although as it turned out as they went through the process, reuse, also of interest to your group, it turns out to be a key thing that will drive change in this area. In user experience, we see a high level of perception that managing the complexity through shared understanding of models becomes a very important attribute of this process. Whereas as we get into the practice of it, it may be that most of the benefits come from automation. We're seeing some measurement in that area, but there's almost no discussion of the benefits of automation that are coming out in the measured domain, and on and on. So this was a sort of interesting starting process. The survey was opened up on November 18th, 2019, and we ran it through February 1st, 2020 in that space. We had 240 people come into the survey. It was about a 30-minute process with a fairly large set of questions. We had 129 people that came into the survey actually go through and complete every question. And then we had various levels of incompletes. And I can tell you, as we analyzed the data, there were people who obviously came into the survey and made it through the first 5 or 10 or 15 questions and then stopped. And there was another set of participants that obviously made it to the end, but just had questions that they chose not to answer in this phase. And so we kind of found that point where the non-answers were randomized across the question set. It turned out to be about 70% answer rate. So of the participants that answered 70%, they tended to move into the random phase. And so the data that I'm going to show you is actually the result of 171 survey responses in the space. The data I'll show you for the text-based questions that we asked was all 240 because we could filter out any non-relevant text answers in that process. And then these are the questions. I'm not going to go through these in detail. I can tell you that they're organized to the capabilities matrix into these 12 different areas. Usage of models or MBSE, management of them, use of them and management of them, and the technical processes, specifically about metrics, model quality, the data management, so moving from models to the data that underlies them, model sharing and reuse, the infrastructure or the modeling environments, a number of free text questions about organizational implementation, which is trying to get to culture, and then a couple questions about workforce and skills, and then a final question that was just demographics. All right, so now we walk through the results. So this was this is demographics information. So you can see we had 48 government participants, 109 industry, and 11 academia. Out of that 171, we went through and via a free text question allowed them to talk about what market they were listed in. And so as expected, aerospace and defense dominated the survey, but we were pleasantly surprised to see some things like automotive start to grow into a bigger role in the space, as well as agricultural and manufacturing and construction and things like that. So we got a fairly good broad set of information, broad set of respondees. We sorted out the industry type also by industry size and years of experience. And so academia, government, industry, and then what the bars show you for size is years of experience. And so you can see clearly that large industry has been at this the longest in terms of number of respondees. So 20 of them were large industry with more than 6 years of experience in modeling in the space. So there's some trends in this data that are interesting when you start looking at the results by the questions, and we'll talk to that. And so this is the bottom line up front. This was the survey results. So when we got all this data, we asked a set of questions, this set that the participants had to indicate whether they strongly agreed, disagreed, or strongly disagreed with the statement that was made in the survey. And so this is just a scoring that we used, where strongly disagree was worth -3 points, a disagree -1, an agree +1, and a strongly agree +3 to give you a relative idea of rough scoring between questions. And so you can see kind of where we are in the state right now. I'll tell you a couple things that are explained a lot more in the report as part of this. So we based the statements that we used in the survey on an organization that would be what the survey calls level 4 maturity. So the maturity matrix that MBSE published basically says level 0, 1, 2, 3, and 4 in terms of our capabilities. It's not necessarily focused on maturity, but we assess these capabilities at this level. And we base the statements for the survey on what an organization who rated themselves as a level 4 capability might say about themselves in the space. And so, it was obviously where we are today in the maturation of digital engineering and model-based system engineering across organizations is there's not very many areas where organizations are highly capable or would rate themselves highly capable. Most of them, I think, are somewhere in the middle. And so, so we gave them so they would tend to disagree or strongly disagree that they're fully capable in these spaces right now. As we go forth, being able to repeat this survey every couple years, we should be able to see some trends where they're becoming more capable over time in that space. And what we'll do is we'll kind of walk through the data for each one of these areas as we move forward. Also note, we collected some information on where the participants were, and just looking at this slide, we had 17 people that listed themselves as being executive management in the organizations, 29 that said they work in product or other management, and then the rest of them doing various roles associated with the process, 92 of which were systems engineers. And that data, it was fairly interesting. So breaking that same scoring into each area by where people said they were, you can see a kind of interesting trend here. So these dark green bars are executive management. And then the sort of turquoise bars are project management. And then the orange bars are the people that are actually doing work, the system engineers in other worlds. And this is cut off in terms of total scores. But as it turned out, executive management rated their organizational capabilities as agree or strongly agree in all but 5 of the question categories. Whereas the system engineers that are doing work rated their maturity as agree or as agreement in only 5. They rated a disagreement or strong disagreement in all but 5. And so we're definitely seeing some evidence of cultural barriers here. Higher level management has a much rosier view of the value that this is going to bring to the organization than the people that are actually doing the work today. So that's one of the reasons why we went off and said we really need to take a look at some of these cultural barriers that are going on in programs right now. Walking through the survey results, MBSE usage would say that you actually have enterprise strategies to use and manage your digital engineering process and model sets. Model management would say you put in place more detailed processes to manage those models across your enterprise portfolios and program sets, and it's linked to your business strategies. And so just pulling out a couple of questions in the space, because they all shared similar trends in the data, we're in the poor to moderate disagreement categories in all of these questions. And then you can say there's generally similar agreement by organization type, organization size, generally similar trends in agreement or disagreement along organization size, and a clear trend to get better the longer you've been doing it across both of these question sets. So you can see the gradual implementation and process. And we would generally expect to see similar trends throughout all these question sets. We didn't necessarily see that, but we're, in terms of integrating MBSE usage and model management into our enterprises, we're seeing fairly consistent responses back from survey participants across all of the demographics, with an increase or indication that we're getting better as we go along. In the technical management side, we started to see a trend that popped up in a number of questions. So technical management looked at our use of models as the basis for our technical processes, and then using those models as the basis for our technical reviews. And so again, this does improve with more experience in the space, but we start to see a trend that appeared several places that smaller organizations are having an easier time of this than large organizations. They're reporting more agreement or strong disagreement with these statements in the space. And so that's leading us to the belief of some of the cultural processes that are in play, which are probably more difficult to overcome in large organizations with larger programs than they are in smaller organizations. One of the things we dove into was a specific question: please identify any benefits or challenges you found in the use of MBSE or digital engineering in the technical review process. And so we will go into detail more on these categories, but this is our first view of what we might call obstacles versus enablers questions. And so we can see a number of things that popped up here that sort of span here's the value of MBSE, improved system understanding, being an enabler, orange bar, but also a barrier in some cases, versus here is the adoption of it. And so you can see, the MBSE methods and processes and our maturity of those is the largest obstacle to adoption of MBSE in our technical review process. Organizational culture being next, customer stakeholder buy-in, but you can also see customer engagement as a value, an enabler for MBSE in the technical role. So it's starting to pop up. So we should see this trend over time. And we'll go into some more detail on some other questions about this whole idea of obstacles versus enablers. But this was the first place where we started to see this blend between here's the value and how would you measure it, and here's the cultural issues and other obstacles to full implementation. This is survey results on metrics. This is one of those things where the dichotomy started to pop up, and the survey participants reported that modeling provides measurable improvements to the process, but they strongly disagreed with the statement that they have consistent metrics for that. So we're seeing, again, a repeat of our literature review that says that there's a lot of perceived benefits of modeling digital engineering in the space, but we're really not to the point where we figured out what those metrics are. The survey will help, or will have helped build a framework for better measurement practices. This is model quality, and so this is way more general than what you're looking at. This was very much looking at the process of quality. Do we have good data and model V&V processes? Do we have good quality assurance processes in this space? And so there's generally moderate disagreement. We could see again where small organizations are doing slightly better than large organizations in this space. this is an area where we might want to dive down and look for some additional data at a much more detailed level. From a data management point of view, I talked about this shift from, what we might call good modeling practices, which have been around for some time, versus authoritative source of truth, which is the shared data that formulates our models. So we ask these two questions. We have effective approaches for managing the data interface between tools, and data is actually managed independent of tools and allows for that portability. And so we expected people to be less mature in this area. They're stating that they have less capability in this area. But also in this space, we can see a fairly strong trend that organizations that are smaller are doing quite better in this. And this may be somewhat due to the demographic result of the survey. They might be organizations that are specializing in MBSE and development in this space. But this is definitely an area where, if you think of the shifts that happen, we're much more mature in how we model things than how we share data across models and manage that central database. Model sharing and reuse. So again, most organizations agree that they have capability to support model libraries for reuse, but they strongly disagree that they're using them consistently to manage their systems. And since reuse is such a strong, value of the whole modeling practice, this is kind of an important area for us to get mature. One of the areas that was discussed here, shared models are being used. You can kind of see here that it's not necessarily getting better with time. So we are still sort of in that learning curve of how do we share data and share models across organization sets. And we kind of dove into this data model discovery and reuse question. And so when we asked the question about what practices organizations are implementing for data discovery and reuse, out of the responses we got, there were 26 of them that said we don't know, we're too immature. 58 said they have. And most of those were focused still on the foundational aspects, building libraries, doing what the tools allow us to do as we do our tool implementation. And we're having these challenges versus things that we'd like to see build up from lessons learned, more advanced capabilities, such as embedding enterprise architecture frameworks, specific model curation processes, developing strong taxonomy and ontology across the organization. So again, we're reflecting, in the space, we're learning how to do libraries in conjunction with our tools, but we're not necessarily developing the specific processes that let us take advantage of digital engineering at this point in time. You would expect that to change. This one's kind of interesting. So we asked a couple specific questions about security and IP protection because the narrative floating around was so much focused on concern about trust, concern about security, concern about IP. This sort of surprised us. When we asked questions about our organization takes steps to make sure that our modeling environment protects our IP or that our modeling environment is secure, we got a very strong agreement with that statement. And when we asked a general question, define processes and work instructions that cover tool selection, use, and data interoperability concerns, we got what you might call neutral agreement with that. So, this is telling us that the tool infrastructure is getting to the point where it's getting more mature in MBSE, and that people have a lot of trust in the tooling environments. Going back to David's example earlier, that doesn't mean that the specific security practices or protection practices don't have vulnerabilities in them or anything like that in the space. This is just the organizational perception of where they are. It does call into question some of the narrative that's been going on, that states' concern over the use of these tools related to security and IP. This is just a counter narrative that came out of the survey results, and is a strong counter narrative. Workforce and skills, getting through the survey results here. You could call it moderate disagreement that we have clearly defined roles supporting MBSE and skills. Strong disagreement on staffing. So I think most organizations believe that staffing is going to be a huge concern as this grows. And not too much disagreement that the training is linked to critical skills, or that we have adequate training for skills in this space. And it sort of follows the normal trends. You would expect this one to be sort of independent of organizational size and improve as you're doing it more longer in the space. Some specific data from text questions. So not surprisingly, people listed the most critical skill for MBSE to be system engineering. This has been very strongly represented in all of our data. Digital engineering is not a cure for bad system engineering. It's a support for better system engineering. And so you can see that, and quite obviously, if you've been doing some of this for a while, descriptive system architecture models are a key skill in the MBSE domain. Being able to do systems thinking, choosing the right thing to model. And then requirements engineering, ideally capturing that requirements traceability is a key skill. So that didn't surprise us at all. We did want to understand emerging skills in the digital engineering domain. And so tool experience in digital engineering came out of that. And so, we're much more dependent on tool expertise when we get into the digital realm and away from writing paper-based or electronic documents in the space. And then some of these emerging skills, besides modeling, include data scientists and simulation engineers, and this idea of model curation or governance, CM of models starts popping up. So we've been following the idea of data as being a driver for this pretty consistently throughout this process. So now we get into some of the free text responses. So we asked 3 questions that you might call benefits, and this is where our literature review came in. And so we can see generally 3 types of questions: benefits from integrating MBSE in our organization, benefits from consistently managing our models, and benefits from the collaboration between disciplines that brings. And so there was some areas where there wasn't really, where people actually said they weren't achieving value from it, but we saw a lot of responses that talked to specific values. And so this is the benefit categories, just repeated. I won't go through them again. This is probably the important chart from this perspective. So we did, across these 3 questions, arrive at a set of 7, what you might call top benefits that were consistent across all 3 questions, but they varied in terms of number of citations. And these numbers here are the number of people who cited this as a benefit in the space. And so, reason for integrating MBSE, reduce cost, reduce time as you go through, but reducing cost is not necessarily the biggest benefit from model management, because it does cost money in the space. So, so you can see how these things come out. Obviously, better information and sharing and communications is a key benefit for collaboration. And then, from a model management point of view, increased capacity for reuse, which turned out to be one of the highest results here. So that was one way to parse the data. What's underlined on this chart are the purple ones. So you can see that it's organized by the red color, the reasons for integrating. But then the value from consistent model management comes from reduced time, improved consistency, improved system understanding, and increased capacity for reuse. And so one of the things that the survey has kind of pointed out to us is that building an effective reuse capability in your organization is probably one of the key things that you have to do. And I think this is something that goes straight to some of the work that y'all are doing in the space. So our long years of experience from software reuse have turned up a whole lot of the different issues with code smells and weaknesses and technical debt that come out of the struggle to build good quality code that can be reused. We're going to have to follow that same trail in the MBSE domain in our models and simulations. So this is the full set. So what we ended up having was, out of that 48 identified benefits categories, we had 45 of them cited in the surveys, some of them only once on this chart. But this gives you, in the data, the full list in that space. Based on time, I won't go through all of it. The one that was really interesting to me, which was this higher level support for automation, was cited way less in the survey than I would have ever expected. So we ought to see that change over time. Looking specifically at metrics, I'll go a little bit quicker here, but this chart just lists the top survey response to the question, identify any metrics that have proven useful to measure performance of your activities. And so pretty interesting here that metrics on requirements traceability and better requirements generation are sort of topping the list right now. Even though they're not necessarily the biggest benefits, they are a strong benefit. Defect and error rates, obviously those things are important in that space. So you take it as it is. The survey goes through the full list, so there's some that were mentioned once that are not included in this briefing. There's a couple categories where the responder said, this is a great benefit, but there were 0 metric mentions in this phase 2. So what we're trying to get to now is can we turn this into a measurement framework? Oh yeah, I did have that slide. So here's some, for instance, increased capacity for reuse, big benefit, but nobody's measured it yet, or at least stated they've measured it yet. So this is an area that's of great concern to me, because this is where a lot of the value is going to come in. Reduce rework, big benefit, but nobody's capturing rework metrics in their modeling, in their MBSE or DE processes yet. So that another area that concerns me a bit. And quickly, I got 15 more minutes. Challenges in enterprise adoption. So we've seen this. Phil showed you the digital engineering working group pain point slide, which I won't repeat here, that we're really looking at these cultural adoption issues in the space. So we're actually going through right now of linking the survey results to the pain points to try and inform both each way for her digital engineering working group. Rob Tadier within COSI did a survey. He did 3 years of surveys on MBSE adoption. And so we have some data preceding this that we kind of used. And we took this in probably quite a bit more depth using the Baldrige criteria for performance excellence, which is an assessment framework for enterprise adoption. You can call it enterprise quality, actually, but it informs an adoption or change process. And so here you can see the full list of the cultural, you might call it, or cultural workforce and other aspects of adoption in this domain. Leadership, communications, resources, workforce, change processes, your MBSE processes, the organizational environment, and then the external environment. And so we coded all of the survey text responses into these categories to try and build out a framework. And So then we start seeing kind of a good measurement model for this domain. So there were 3 questions. One was obstacles to implementing MBSE. One was enablers to implementing MBSE. And the third was changes needed to implement MBSE. And so now we start to see organizational culture, workforce knowledge and skills, leadership support. Those are the biggest obstacles in the space. And then going on down to a number of others, and there's a fuller list in the survey report. MBSE tools, which were very strongly near the top in Rob Cloutier's previous surveys, are starting to drop down the list. The tools are getting better in the space. And legacy and current processes and overcoming those tends to be probably consistent with previous surveys. Question? This looks at enablers. And so now we see leadership, support, and commitment, which was the 3rd strongest obstacle, is the most important enabler in the space. People willing to use the tools, workforce knowledge and skills, a new word that shows up, champions for it in the organizations and demonstrating results. So we're starting to see a kind of combined set of things in this place. And then looking at changes, having MBSE methods and processes to work with and implement, and training and tools, those things would start to become important in the change process. And this is probably the most interesting because it lays all those things on top of each other in terms of the space. So I'm trying to figure out where leadership shows up in here. Leadership understanding of MBSE shows up here, but leadership commitment is much higher up on the list. So what we're doing with the survey result is we're actually trying to build right now what we might call an assessment framework to judge your change process in your digital engineering transformation based on this Baldwin criteria and the data that came out of the survey. And that's being worked on right now under the project we're doing with Phil. Some things that we could derive out of this from the Baldwin framework. So here's just a set of statements, and I won't go through those in detail in this space. I want to leave a little bit more time for general questions. So this is, I think, generally the last slide. So this is going back specifically to metrics. And so what we've done is we've looked at percentage of statements from the survey data and percentage of statements from the literature review, and we've just converted them to percentages. The literature review didn't look at adoption in the space, so it's not assessed in here, but it was in the survey. And so this is a normalization as of today that tells you what are the top metrics areas that we should be interested in. For quality, it's cost, defects, errors, traceability, support for integration, and improved system quality, which is kind of a high-level nebulous thing. And then in the velocity agility side, consistency and time and capacity for reuse come up as the top things. And so all of this is going to hopefully produce a couple of other reports, which are some guidelines to organizational change management and measurement for organizations to look like, which is the secondary report that we'll